This video is going to explain how to do integrals that will end up as logs. And so most of the time you want to look for the denominator if there's a fraction, and that's when you let your u equal. So in this one, x cubed minus 3x squared, du is 3x squared minus 6x, and then you substitute just like you did before. I'm going to erase my handwritings. So we have the integral x squared minus 2x over u, and substitute in for dx, du over 3x squared minus 6x. And you end up with an extra 3 in the denominator. So we're going to factor that out to the front. And so then factor out that 3, you get 1 over u du. Integral that's u prime over u. So the integral is the natural log of u plus c. So go back to your original u. We always do absolute value because we have to have a positive natural log, so the absolute value, make sure that's true. You take the derivative to check, you get 3x squared minus 6x over x cubed minus 3x squared times a third, and you should end up back with what you did. This 3 cancels out, and you're back with where you started. That's a good way to check it. Number 12, let's u equal 9 minus x squared. Having trouble with my pen. So du equals negative 2x dx equals du over negative 2x. Same steps. Substitute. So we have du over negative 2x. The x's cancel out. And this is u to the 1/2, sorry. So we're left with negative 1/2 1 over u to the 1/2 du. That is not equal to u prime over u, but it is something we can integrate as a power. That's u to the 1/2 divided by 1/2, which is the same as multiplying by 2. 2 times negative 1/2 is negative 1. Final answer, plug in your u. There you go. This one, again, we have the power is 1 less in the numerator than the denominator. I multiplied out the x squared plus 2x, so u is going to be the denominator. Du is 3x squared minus or plus 6x. Substitute. Dx is du over 3x squared plus 6x. That's 3 more than x squared plus 2x. So you can factor out a 3. One-third integral of 1 over u du. Integral of 1 over u du is natural log. There you go. Take the derivative if you want to check it. 3x squared plus 6x over x cubed plus 3x squared minus 4 times a third, and you're back where you started, so you know that you are correct. Okay, this time we have one of the special cases where the numerator is 1 more than the denominator, so we're not going to ever get u prime over u with substitution. So the strategy you want to use is to use long division and see if you can write it as a different function So we're going to do division. We're going to see x goes into 2x squared, 2x times, it's like regular division, you multiply, bring it down, and then you subtract. 7 minus negative 4 is 11. And that is 11x. Whoa. Pause for error. Alright, fixed your error. 20, so it's 11x minus 22. Subtract. Negative 3 plus 22 is 19. Key is that you write your 19 as a remainder and not keep dividing. So we're really taking the integral of 2x plus 11 plus 19 over x minus 2. It's not a u substitution. Integral of 2x is x squared. Integral of 11 is 11x. The integral of 19 over x minus 2 is 19 ln x minus 2 plus c. So the 19 is just a constant, and then the 1 over x minus 2 is where you get your natural log. So we do long division so that we end up with a remainder where the power of the denominator is 1 more than the numerator. And the reason why, if you take the derivative of this, it's going to all be over x minus 2 eventually, so if you take the derivative of this, you get back to where you started. Now we have, let's get serious in here, we have x plus 5 in the denominator, and the numerator is x cubed, so we're definitely going to have to do long division. So you see a pattern, you're going to do long division whenever the numerator is greater than the denominator. So when these so that our last term will be a natural log term. So x cubed plus 0x squared minus 6x, having problems, minus 20 divided by x plus 5. And you'll see that I put a 0 placeholder for the x squared because when we do division we want to keep our terms lined up. So x goes into x cubed, x squared times, and I multiply, so x cubed plus 5x squared, that's going to be subtracted, goes in negative 5x times, always keep bringing down the next term, negative 5x squared minus 25x. Then we have negative 6 plus 25, which is 19. X minus 20. X goes into 19x 19 times. And now we're going to subtract negative 20 minus 95 is negative 115. I already brought everything down I can bring down. That's going to be my natural log term. So I'm integrating the new expression. Integral of x squared is 1/3 x cubed. Integral of negative 5x, negative 5 halves x squared. Integral of 19 is 19x. And then 115 natural log x plus 5. Again, plus c. You're gonna start to notice anytime you have this, your shortcut is you're gonna factor out a negative 115, and you're gonna have the natural log coming from that because it's u prime over u. U prime is 1, u is x plus 5. So the last term is your natural log. Another one where the numerator is greater than the denominator, so it's set up for long division. Change the form. X squared goes into x cubed x times, losing with x cubed plus 3x. I'm lining up my terms. I'm going to subtract that. So negative 3x squared plus x minus 9, bring down your 9. X squared goes into negative 3x squared, negative 3 times. Negative x squared minus 9 leaves you with a remainder of x. So we write it over x squared plus 3. And so we now have a power in the denominator that is greater than the numerator, which is what we want. So we're going to integrate that expression. Integral of x is 1/2 x squared minus 3x. That's the part we already know. And the integral of x over x squared plus 3, you could do this as a u substitution. Let u equal x squared plus 3. du equals 2x dx. dx equals du over 2x. In other words, we're going to be dividing by 2. So we have x over u and du over 2x. X's will cancel out, so we end up with 1/2 integral of 1 over u du. So we have this portion and this portion of our integral. We're going to add the last part, would be plus 1/2 ln of the u we picked, which was x squared plus 3, plus c. Sorry, it's all kind of crowded. You can't see it all there. Okay, so number 22 is a different form. It has a natural log already in it. Let's go ahead and change the form a little bit. Move the 3 out because it's an exponent. So we have 1 over 3x ln x dx. There's no powers here to select your u, but in this case you want to let u equal natural log. du would be 1 over x dx. dx equals x du. And then you substitute just like normal. 1 3x u dx is x du. So the x's cancel out, and you have 1/3 integral 1 over u du, which is this 1 over u du is what we're looking for. So the integral of 1 over u du is a natural log, and your u just happens to be ln x. So we have ln x. This is one of those where we took the derivative and you got kind of a funny answer. So those are the basic examples of integrals that you have to be able to work out. Again, what we look for is if the numerator is less than the denominator, we can go ahead and substitute. If the numerator is greater than the denominator, we want to do long division and get to the last term. So the last term is a natural log. If there's a natural log in the denominator, you're going to set that equal to your u. Those are your basic strategies.